starting Unit 2 Angle Modulation in Communication Theory. This is the syllabus of angle modulation, that is Unit 2. So now types of angle modulation. So here angle modulation can be classified into two types. First one is frequency modulation and second one phase modulation. So now phase modulation. So phase modulation is defined as the process by which changing the phase of the carrier signal in accordance with the instantaneous amplitude of the message signal. So here amplitude and frequency of the carrier signal is constant. Instead of by using the frequency modulations means the definition will be changed. That is the process by which changing the the phase. In frequency means we can use frequency of carrier signal in accordance with the instantaneous amplitude of message signal. So in here in a frequency modulation, the amplitude and phase of the carrier signal is constant. So now we use the phase modulation. So here the amplitude and frequency of carrier signal is constant. So now we generate the phase modulation signal by using the PM modulator. So here the input of modulating signal is connected to PM modulator, then amplitude this message signal and we get the PM wave. Next, instead of PM modulator we can use the differentiator. So here the modulating signal is input, it is connected to the differentiator, that is differentiator can be used to do this modulating signal can be differentiate and then it will be connected to the FM modulator. So FM modulator and also has the another one input, that is carrier signals, that is a high frequency signal. This high frequency signal and modulating signal can be combined and we get the PM wave, that is PM phase modulation signal. Next one, how we going to representation of the PA signal means we can obtain by varying the phase angle phi of carrier in portion with the amplitude of modulating signal. So here the modulating signal, that is message signal or baseband signal, Vm of t is equal to Vm cos omega mt. That is equation number 1. So here m it is representing the modulating signal V of m. So here the m is represented the modulating signal. So here Vm of t is equal to Vm cos omega mt. In carrier signal we represent the C. So here Vc of t is equal to Vc cos omega ct. After amplitude modulation, the equation of the carrier is represented as Vpm of t is equal to Vc cos theta. That is the equation number 2. In the instantaneous phase of the modulating carrier and it is sinusoidally carries the portion of the modulating signal. Therefore, after phase modulation, the instantaneous phase of the modulated carrier can be written as theta is equal to omega ct plus kp Vm of t. That is equation number 3. So where kp is the constant proportionality of phase modulation. So here the equation 1 and equation 3, finally we get theta is equal to omega ct plus kp. Here the Vm of t is the modulating signal. So this equation can be substituted instead of Vm of t. So we get theta is equal to omega ct plus kp Vm cos omega mt. Next, modulation index. So Vp modulation. So here kp Vm is defined as the modulation index of PM. So next, Vpm of t is equal to Vc cos omega ct plus mt cos omega mt, the equation number 5. So in PM wave can also represent Vpm of t is equal to Vc cos omega ct plus phi m cos omega mt. So mt is instead of we can put the angle modulation phi m. So next, modulation index. So here the modulation index of PM is defined as the proportional, that is amplitude of modulating signal to the frequency of the signal. So here MP is equal to Kp into Vm. Kp is the deviation sensitivity, radians per volt, and Vm is the peak modulating signal amplitude in volts. So here the modulation index of PM. So it is proportional to amplitude of modulating signal, that is modulation index of PM.